In this question, it is given that if z be a complex number satisfying mod of real part of z plus mod of imaginary part of z equal to 4, then mod z cannot be. To do this question, let z is equal to x plus yi, and this means mod of x plus mod of y equal to 4. To do this question, first of all, we draw the graph of this equation. It is clear that if we write minus x for x, the equation remains unchanged. This means the graph of this equation will be symmetrical about y-axis. And because by writing minus y for y, again the equation remains unchanged, hence we can say the graph of this will be symmetrical about x-axis also. That is, the graph of will be symmetrical about both x-axis and y-axis. Hence, to draw the complete graph, we just draw the graph in first quadrant. Once we have got the graph in first quadrant, the graph of second, third and fourth quadrant can be easily obtained. And for first quadrant, it is clear that this equation can be written as x plus y equal to 4. And we know that x plus y equal to 4 represent this line where this point is 4 and this point is also 4. Any point on this line satisfies this condition, and hence the graph of this can be obtained from the graph of this by using symmetry. That is, if I take y-axis as mirror, this part will be obtained, and after taking x-axis as mirror, this part of the graph will be obtained. This point will be minus 4 and this point will be again minus 4. And we know that mod z represent the distance of z from origin, and z here is x plus yi. The graph of this means z moves anywhere on this square. It is clear that as z moves anywhere on this square, because graph of this is symmetrical in all the quadrants, hence we concentrate only on the points in first quadrant. It is clear that out of all these points, this point is at maximum distance from origin. Agreed, this is also at the same distance. And if I draw perpendicular, this point is at least distance from origin. Hence, I can say the greatest value of mod z is less than or equal to 4. And the least value of mod z is this distance, and because angle is 45 degree, hence I can say OP, which is the least value of mod z, becomes 4 sine 45 degree, that is 2 root 2, because this length is 4 and this angle is 90. Hence I can say as z moves on this square, the value of mod z always remains less than equal to 4 and greater than equal to 2 root 2. That is, we have got the result that this and 2 root 2. Or we can say mod z lies between under root 16 and under root 8. Hence I can say the value of mod z can never be root 7. Therefore C becomes the correct choice.